Good morning, good afternoon, and good evening, everyone, wherever in the world you may be joining us from today. My name is Francesco Del Carpio, and I am the Operations Coordinator for CFAL York. I would like to officially open the 9th session of our Climate Change Emergencies and Cultural Heritage Speaker Series, which is being presented in partnership with Heritage Ottawa with a land acknowledgement. We acknowledge and recognize that many Indigenous nations have longstanding relationships with the territory upon which our campuses are located that precede the establishment of York University. The area is known as Tkaronto and has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat. It is now home to many First Nation, Inuit, and Métis communities. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. The territory is subject to the Dish with One Spoon Wampum Belt Covenant, an agreement to peaceably share and care for the Great Lakes region. As this is an online event, our participants may be joining from various locations, so I strongly encourage you to learn about the traditional land upon which you are located. With this, I welcome our moderator, our speaker, and our participants from around the world. Welcome to our webinar. Without further ado, it is my great pleasure to introduce our moderator today, Dr. Rosa Milito. Dr. Rosa Milito is a conservation architect who has worked extensively in Canada and Europe for over 25 years. Beside her professional background, she has contributed to academic research and teaching in Europe and in Canada. She is currently an adjunct professor at the Dalhousie Graduate School of Architecture and has recently founded Heritage Workshop Studio Limited, based in Atlantic, Canada. Rosa works at her studio with the vision of leveraging diverse cultural perspectives to protect and enhance culturally significant places and integrate them in sustainable development projects. She is a CAHP member and vice president of the Atlantic chapter of CAHP, and is involved with ICOMOS activities for sustainable development and climate change for more than a decade. She is Secretary General of the ICOMOS International Scientific Committee on Energy and Sustainability, and has served for 2 terms as Director of ICOMOS Canada and continues to contribute to the ICOMOS Canada World Heritage Committee. Dr. Milito, thank you very much for moderating today's session, and the floor is yours.
Hello, everyone. Thanks for inviting me to chair this session and for the pleasure to introduce Dr.Henrik Schoenefeldt. Dr.Henrik Schoenefeldt is a professor of sustainability in architectural heritage at the University of Kent School of Architecture and Planning. He specialized in environmental design with the MPhil and the PhD from the University of Cambridge. And his main research interest is in historic principles of environmental design, both as field of scholar research and architectural practice. He's currently seconded to Parliament of Westminster to lead a large research project on sustainable conservation of the Palace of Westminster, which is also the subject of his recent book, Disruptive Environmentalism, published by Routledge in 2021, which I really recommend. I just got it, and it's a great book. He will introduce us today to a new way of looking at historic buildings through the lens of historical approach to the environmental design and how they can inform adaptive reuse projects. And he will also talk a little bit more and let us a little bit know more about his academic research, currently focusing on the sustainable conservation of Palace of Westminster. So without no further delay, I'd like to hand the floor to Henrik Schoenefeldt. Thank you.
Thank you for introducing me. So just going to share my slides. So can everybody see and hear me?
Yes.
So I've given this talk the title Architecture Biographies of Resilience. And why I've used the word biographies is because it gives us a different way of looking at buildings that have lived, essentially, like us. We as humans, we talk about the life of people as biographies, but we can also talk about the biographies of buildings is essentially the history of buildings in use. And we can look at buildings in use also from a climatic perspective. So how have buildings in the past that were designed at a particular moment in time continued to evolve and adapt to the changing environment in which they were placed? Because the environment, particularly if we think in much more broader terms, is always undergoing change. And through historical research, it is actually possible to understand how in the past climatic and other environmental factors such as urban pollution, for instance, etc., have shaped a continual engagement with the relationship between buildings and the environment, and how buildings at times had to be repeatedly adapted using the new advances in technology, etc., and new requirements to that. So therefore, the challenge that we have now with climate change to adapt historic buildings, which raises a number of questions, how far are we allowed to change the historic environment in order to meet the new challenges, is not something that is new. So what I hope to explore a little bit of actually how maybe we need to reframe heritage as something that is inherently changing, and that the changes that are now ahead of us that are probably much more fundamental than those that were in the past, because it's the rate of climate change that we're seeing now, the principles are similar, is that buildings need to be accepted to change. And that is part of a tradition of architecture. So this is sort of an opening statement I would like to make. And one thing to start off with is that we need to think about an environmental heritage. So when we're looking at historic buildings, they are of architectural significance, but they also have behind them an environmental heritage. And this essentially applies to any building we look at, will have behind it some form of environmental intelligence behind them that reflects the particular way the people who had designed those buildings originally thought they could negate the relationship between the building and the environment. And there's a global phenomena of architectures that responded to this. And here I've just taken 3 examples of buildings in different parts of the world, of buildings that were distinctive in terms of their environmental response. Probably a lot of you are familiar with the architecture of wind catchers in Iran. This is sort of seen almost like as a symbol of vernacular architectural response that's globally known, but also other buildings that might be less associated with environmental thinking, like, for instance, the Natural History Museum in London, which is a 19th century building, is also for its time a building that engaged with particular ideas of how buildings relate to the environment and the role of technology in that. So that we therefore can talk about an environmental heritage in architecture. And one key thing when we're looking at this is to understand that actually architectural history, so architectural historians, have for a long time really not given sufficient credit to the fact that the development of architecture has been shaped in non-fundamental ways by environmental and climatic considerations. And this was in the 20th century, there's one individual, Rainer Benham, was one who was very outspoken critics of architectural historians in that respect. So he published a book in 1969, it's quite a long time ago, and a period where we maybe not necessarily expect environmentalism to be at the forefront of architectural writing, but as Benham was actually making an argument that actually the advances in environmental technologies should be part of the canon of architecture history writing, not a side interest of architectural scholarship. And what's interesting is that this book that was originally published in 1969 was written at a time of great enthusiasm about technological advancements and the freedom that development, such as air conditioning and mechanical ventilation, has provided to architectural development. There was a second edition that came out in 1984, post-oil crisis, where he was actually criticized quite a lot for the types of arguments he was making in the 60s in favor of embracing technological advancements to allow new architectural opportunities. And this quote here, I just would like to read out. I think it captures something quite about a shift in perspective that's happening at that time. The waning confidence of architecture and their ability to deal with energy problems or opportunities was increasingly manifested in the form of a call for a return to traditional modes of construction, inherited wisdoms about location and orientation. Rather than calling for more efficient air conditioning, the call was for the abandonment of air conditioning altogether, no matter who might suffer. And this is, I think, quite an interesting strident comment he was making in response to the criticism he was receiving at the time, that was showing some of the implication of the modern opportunity that came, that there were also implications of this reliance on fossil fuels. And he was rather reticent to accept that there might be some people calling almost a return to the vernacular traditions of the past. And in some ways, you might argue that it's indeed quite a naive way of looking at it. So what I'm not going to try in this talk is to promote that we should uncritically look back at the past and think the past is offering all the solutions. What I'm arguing is that an awareness of actually how historic buildings were designed from an environmental point of view is an important starting point to find a more sympathetic approach to adapting buildings today. So that is the point I would like to make here. So we are engaging with this sort of criticism, this between modernity and traditional principles, is we need to find a solution that finds the midway between those two approaches of dealing with the adaptation of existing buildings, not disregard the historic principle as completely outdated, nor to completely throw out the modern achievement, modern technologies as being a problem. So it's finding the balance. And what's interesting is this interest in environmental heritage, of course, is a global thing. I want to really highlight this. Canada has a lot of traditions of indigenous cultures and their way of living with climate. That is part of this vernacular tradition. And there's wonderful work that's been done, particularly by Paul Oliver, who is trying to catalog and map some of these rather under threat vernacular traditions and ways of living of architecture. That's part of the story of actually a knowledge and intelligence of environmental design that's embedded in historic structures. So, so this is not just entirely limited to studying buildings in the UK, of which I may be focusing on today. Methodologically speaking, this is something that can apply to any context. And as interesting as this idea of revival, that in some ways that Bannon was criticizing, there were people making this naive claim the past can provide solutions to a more low energy future, is not actually a thing that was isolated. You have architects working in Egypt, for instance, who was actually making this claim that vernacular architecture can potentially provide solutions to providing more affordable housing using local materials and established methodologies of construction, but is also recognizing in another book. So he wrote this book, The Architecture of the Poor, in 1973. In 1986, he wrote another book. There's almost a counterpart to it that highlights the vernacular climatic principles that are embedded in the same kinds of housing he was promoting as a model for a more low energy future. So, so it's interesting is there's an interest here in historic principles in a way of looking forward into the future. Whether this is realistic or not, but this is indicating this is not just about studying the past, but it's actually about engaging with the past to look through the lens of our current challenges. And we see actually some of these ideas actually put into practice in more recent times. So the Door Office project here in Senegal, a secondary school from 2022, is an example of a modern attempt to reinterpretation of some of these vernacular principles of designing buildings with local materials and also adapting to climate that didn't rely on heavily mechanical solutions that are heavily energy intensive. So it's an attempt to actually, as Hassan Fatih did in the 1980s, trying to re-engage with those passive solutions of the region and appreciating the intelligence that we can gain from them. So this overlaps quite interesting with other pieces of work that looks into this idea of a rational regionalism. So regionalism, which is very often associated with styles that are very regionally distinct, but that regionalism has also an climatic dimension. So Victor Olguay, in his book, Design with Climate, is actually exploring that notion that there's actually a form of regionalism, of climatic intelligence, of adaptedness to the local conditions, that we can potentially learn from to make our buildings more climatically adapt, rather than relying entirely on technologies to adapt to the environment. And to me, this actually raises an epistemological challenge, because in some ways we have a schism at the moment where we got, on one point, a history of architecture that to some degree hasn't sufficiently engaged with the climatic aspects. So the scholarship in this area is growing now. It has been growing since Benham is written. A lot more scholarship has emerged in the area, but there's still quite a lot of architectural history that doesn't really engage with the subjects. So we have an emerging history of environmental design, almost as a sideline subject emerging in the scholarship. So famous people that are that were writing in the areas, like Dean Hawkes, for instance, writing a lot for a long time about the history of environmental design in architecture. And we find actually something rather similar emerging. So we got the schism between architectural history and history of environmental design. But we also got a problem where we're looking at architectural heritage problems today as being a contemporary issue, without the understanding that actually architectural heritage is actually, in its relationship to climate, has also a historic dimension. So I believe that actually architectural history is a means of establishing a dialogue between questions of environmental design and historic buildings today, and the environmental principles that are inherent in the design of those historic buildings. So when modern engineers come in and want to introduce new technologies, rather than trying to work with the historic environmental principles, that can be an issue. So could modern environmental engineering interventions be informed by an understanding of the original principles of environmental design that's inherent in the building, and establish a dialogue between those two? And that's what this subject of my research is trying to bridge, those two gaps between architecture history and the history of environmental design on one side, and between modern environmental design practice and modern heritage practices. So that is sort of a way of conceptualizing that, and we're seeing this in this contrast between Rainer Benham bringing an environmental dimension in the 1960s, and we have another book that was written almost at the same time, The Sources of Modern Architecture. We talk about some of the same buildings that Benham talks about it, without making any reference to the environmental dimension of the development of modern architecture. And what is another element I would like to add to this, and this is something that people like Rainer Benham and so on don't really engage with, and I think architectural history in general doesn't show very much interest in general, is the fact that buildings are occupied for a long period when they're built. So we might go back to the time they were constructed and understand how designers were thinking about climate and environment. But what we do know is the buildings that we see today are rarely really the building that they were when they were constructed. Buildings are heavily adapted, even if they don't necessarily appear to be. Some buildings are quite deceptive, including the Palace of Westminster, might on the surface appear quite original, but it's actually heavily adapted as a lot of other buildings of its period. And there is this book by Stuart Brand, which was actually written in the 90s, which tells us actually about what happens to buildings after they're built. And he talks about lots of different changes, and particularly the aesthetic changes, the internal changes of buildings. But the way buildings were adapted environmentally over time is part of the story. So a building that might have been designed 100 years ago with particular environmental technologies in mind, then those technologies are no longer in use, nor are the passive principles that are embedded in some of this design are still in the consciousness of those dealing with the buildings today. So a part of my research is to actually almost build on that four-dimensional view of architecture, seeing buildings over time and seeing buildings after completion, that the relationship to climate is actually ongoing. It's not a static relationship. And we're seeing this, examples this in buildings. For instance, here is a building, the state capital in Chandigarh in India, Kubidie, that we go around that building, we're seeing a lot of air conditioning units being retrofitted into a building that wasn't designed for air conditioning. So there's an example of a building that was designed with a very particular way approach to climate that's now been adapted to new technologies. And the question is, if that change again today, would we approach it differently? Is there a way we could go back to the original principle that were light without air conditioning and making these buildings work? This is a very important question. On the left-hand side, is showing another building, which is in this case the UK. This is actually in the Houses of Parliament, under the House of Lords Chamber. So this is the upper chamber of the British Parliament, where in 1966, the first time air conditioning was introduced, modern air conditioning. Before that, from 1854 to that point, it was climatically controlled using a Victorian approach to climate control, ventilation and cooling, etc. That was to a large extent passive. So this technology marks a transition, a technological transition in the history of the building, where the original principles are now at this point have ended. So in order to understand this relationship, the original relationship and later relationship of these buildings to climate through technology, we need to essentially look at buildings in a much more comprehensive manner, and I would describe them as deep case studies. So we need to look at the historic buildings, its anatomy, the way the building is built, both in its historic form and in its current form, but we also need to understand the process behind them. How were they originally designed? What were the original objectives and ideas behind them? But we also got a history of these buildings once they were completed. How were they operated? And how were they continued to be adapted and why? So that we're really understanding these buildings over their lifetime. So I talked about biographies of buildings. That's what I'm talking about here, is that we really want to understand the whole life cycle of a building climatically and how the buildings fared and respond to climate. So I've written a book, and this is part of a research project. This was actually in the first half of the project, where I've actually looked at the original design of the Palace of Westminster and understand what were the original ideas behind it and how were they implemented and how well did they perform originally. So trying to really critically assess that in great level of depth. And this is the first study to do that. There is a little final chapter in this also that looks a little bit what happened to the building after it was completed, and seeing what type of investigations were done and why over time after the building was completed. But it focused very much on the original systems and how they were performing over the lifetime of the system. So in this case, almost 100 years in use. And one key thing with the study is that the building had essentially, there's one aspect of the building which are the systems. So we're talking about heating systems, cooling systems, the sort of plant that was used. And then we got a system of fluids that were running through the building to supply and extract air from rooms. So these are the things that are physically evident in the building. But we have also other things that are slightly more ephemeral, that are also less obvious related to climate. And one of them is the role of the design of the building fabric. So how far do, for instance, the design of the windows were informed by climate considerations, particularly the original windows, which are not always in place anymore. And then we also got what I would describe as auxiliary environmental elements, most of which have now disappeared, such as, for instance, shading, natural ventilation strategies, the original approaches to double window systems, so an early example of insulating through double windows. So these were more ephemeral elements that we don't find in the building anymore today, but we can find in the archival evidence and historic photographs and so on, of understanding of actually how a system in the building and these auxiliary elements work together. So there is a relationship between architecture and technology in that building that needs to be understood fully in its design. And one key thing that's really important about 19th century buildings, so the Palace of Westminster was rebuilt after the fire of 1834, a big fire that destroyed the medieval complex of buildings, and then was rebuilt after that period using 19th century technologies of construction, environmental design. But it was also a period of transition, a period where actually modern building services, the idea, for instance, having ducted ventilation, central heating, and so on, were existent already, but they haven't necessarily been employed at a very large scale at this stage. So, so this building in the Palace of Westminster is quite unique in that it actually attempted to integrate and systematically a centralized ventilation system where all air was supplied and extracted centrally, and also still to utilize some of the more older techniques of simply opening, closing doors and windows for ventilation. So we're in a state of hybridity where we have old ways, non-technological ways of managing environments together with more technological ways of managing the environment that were emerging at the time. And that is sort of mirrors in some ways what we're trying to do today in sustainable architecture, where we're trying to actually return to as much as possible passive means, while at the same time it's also harnessing the opportunity of modern technologies. So the 19th century, the first half of the 19th century was in a similar stage of transition, where we see two stages coexisting. So the type of modern technology we find, so here's an example of a big plant room that provided steam power to drive fans and heat. So that was plant that's sitting in the building. That's no longer there. That disappeared. And was replaced by newer technologies over time, the way the building was heated and or ventilation fans were driven. But it also had a lot of things that were passive. So particularly the use of towers to drive air through the building. And to do so, the entire building was actually designed to have large spaces in it. So the whole basement was used to distribute air through the building. That air was then brought into the spaces and then extracted roof level through towers again. So essentially what they were doing here is they used the architecture, building towers, to create natural convection. So use the natural tendency of hot air to rise to move air through the building. So these are essentially, and these elements are still in the building. So the building is still essentially 25% of the internal space of the building is still occupied by these historic voids that was used to distribute and condition air within the building. So this is a contemporary photograph where we can see some of these historic ventilation towers still adorning the skyline of the building, but a lot of people are not aware of the fact that these towers were actually functional features of a historic ventilation system that were added on for that specific reason. They were not part of the architect's original vision. They were added on as the project developed, and the architect accommodated them into the design and make them seamlessly part of its picturesque composition of a Gothic revival building. But if you're looking into the historic details, we're finding out we really can learn of how these towers functioned. We're seeing they were not just purely ornamental elements, but they contain smoke flues, for instance, and air vents in them to extract the air and smoke from the building. So they're using natural stack principles to drive the air through the building. And we're seeing that these architectural elements become quite bold. So here we've got some historic images of some towers that have actually now disappeared. Some of them haven't survived. So here on the left-hand side, you see a square tower for the House of Lords ventilation system. On the right-hand side, you're seeing the House of Commons system of a shaft that was destroyed in the Second World War. So this is part of the architectural language of a 19th century ventilation system that shaped its architecture in really fundamental ways. And in order to understand this, I had to study thousands of documents, which included letters, drawings, sketches, parliamentary reports, to really gain a full understanding of the original intention behind it, how it was implemented, etc., and also how design ideas were discussed and evolved over time. So we can dig deep into the original environmental thinking of its time and compare that to the way we think about it today. But aside from the archival research, because I'm seconded to Parliament, I can also study the building itself. So I spend a lot of time to systematically map the surviving features of that historic ventilation climate control systems. And here's a few photographs of ventilation shafts and air chambers in that building. That gives you an insight of actually the quality of these spaces. So some of these are spaces on the floors, some of these spaces are flues in walls, and others are spaces that you find in the roof spaces of the building. So this 25% of the entire space are occupied by voids like this, hidden within the fabric of the building, but big enough to enter and walk through. And when we're then looking at historic evidence, we can also understand how these spaces actually originally functioned. So you still find those spaces in the building, but they're no longer used the way they were originally used. So historic photographs showing us the equipment that was placed inside them. Also, we're seeing that actually floors, for instance, were different in the past. That, for instance, the House of Lords chamber had perforated floors to supply air into it. Those iron plates are still there in place today, but they're all covered up now and sealed. So this was part of the historic system. Equally, when we're looking into the fine interiors of some of the committee rooms, for instance, we're seeing that a lot of the ornamental detailing was actually shaped by ways of supplying, extracting air. So we got ceilings with perforated woodwork, we got skirting boards, we got wainscone paneling that acting for the air supply. We even got furniture that contains wooden ductwork to supply air into the rooms. So here's just another example of, so you see the House of Lords ceiling on the right-hand side, a very ornamental ceiling that is actually incredibly light and perforated to allow hot air to be extracted through that ceiling. So that's really important to realize that even those ornamental features were shaped by historic environmental thinking. So these spaces, though, are not just on the floors and inside the roof spaces. We also find that the entire walls of the buildings are permeated by vertical shafts that can be mapped, and to understand how they're all interlinked and how as a system they worked in the original design. In some cases, some parts of the building, like the House of Commons, which was bombed in the war, has been lost entirely. But through my archival research, for instance, it was possible to reconstruct the original design and produce drawings to show what it used to look like and how it was operated and how it had performed. So to really learn and critically evaluate these historic approaches to climate control in these important spaces. And this research also then underpins an exercise of surveys and trying to use modern computational models or building information modeling to essentially capture the regional ventilation system in 3 dimensions. So here we got a model, a Revit model, that captures all of the voids surrounding the House of Lords chamber, so that we now can actually work with these principles and these systems and rethinking whether these could play a role in the future design of the building and be informed by this understanding. So these models form quite an important bridge between the historical research and the design studies to be done. And here's another view where we see on the left-hand side the basic building information model, which just shows the interior surfaces, and another one where the mass of the building is turned transparent, and we see now the voids that were modeled as a result of the research, to showing the hidden ventilation system within the fabric of the building. So systematically documenting that, and this is sort of really illustrating that these researchers are forming architectural practice. So, and I've actually written also some articles for professional journals. Here's one for the Historic Institute of Historic Building Conservation journal, an article exploring what to be seconded into a large project and leading as an academic these projects. And similar, another one in the Royal Institute of British Architects journal. I've written a piece on this journey of actually moving from academic scholarship into something that informs directly into the practice of environmental design. This is just another example, the SIPSI journals and the ASHRAE journal. So these are journals in the professional building services engineers. ASHRAE is in the United States, SIPSI is in the UK, although they're quite international organizations now, but they've shown great interest in this scholarship and seeing relevance of this to practice. So that is about actually capturing the architecture of this historic system, but we need to actually go beyond just thinking about them as physical artifacts. We also need to understand how they were operated. In particular, the ventilation system, a lot of them were operated manually by people. They had valves in them to manage the climate conditions in them, to also manage the fire risk of some of the voids, so the fire couldn't spread through voids. That had valves, dampers, to try to control that. So here's a cross-section through a part of the Palace of Westminster, where you can see in gray all the voids going through floors and ceilings, and how the air is traveling through them, and the position of dampers that were used to control the airflow through those spaces. And we can actually map them. So as part of my research, I was actually systematically mapping the surviving historic dampers that staff are operating to control the system. And this is part of this building's resilience relied very much on the operational regimes, or how well the building was managed by the people in charge to respond to changing environment around them. And what's interesting is some of these dampers we have remains as a control mechanisms of pulleys where people were pulling to open and close valves. We got historic drawings showing us how these valve mechanisms worked in the building. A lot of them are now bricked up and lost. But what we also have, we have archival evidence telling us how the building was operated by staff and the type of logbooks that attendants kept with temperatures, operational procedures. We have also reports of studies that were done over the lifetime of building to understand how well they performed. So we can really critically evaluate their performance based on those historic evidence. And part of my research, I spent a lot of time studying them. And one key thing is, and this is something that people might forget, that actually a lot of public buildings in the 19th century, in Europe in particular, in the United States, North America, were actually monitored manually using rather simple methods like thermometers to monitor at least the temperature in these rooms and record them. So we have a historic record of historic climate conditions and historic internal conditions that we can study. So here's an example, for instance, of a historic climate logbook that logs the internal temperatures, while we also got historic weather data that corresponds to that. And we got data on the occupancy. So we can do actually critical evaluation of actually how the buildings were performing under the climate conditions they were encountered, including eyewitness reports too, how people felt in those environments. So here are more subjective accounts of major users, in this case, members of parliament and members of the House of Lords, commenting on the environment they were encountering in the 1850s. So the type of climate experiences that are in the past. And what was remarkable of a public building like this is that they were actually systematically recording people's experiences alongside monitoring it through measurements and that this feedback was used to manage the buildings. So they were essentially proto-intelligent buildings, but it was staff who were managing the building's responsiveness to environment. But this wasn't just about the day-to-day operation. They sometimes got scientists in to study buildings and how they behave in a more systematic manner, and also propose improvements. And this, of course, was evolving as sciences, as the natural sciences were evolving. They were evolving more and more advanced techniques and trying to understand the behavior of the environment in these spaces and how they can be improved. So advances in the sciences were quite critical to seeing how buildings were adapted to climates, is largely informed by better understanding of it. And this also sometimes engages with questions of pandemics that we have recently in the world, like the COVID pandemics. We had a similar situation in the early 20th century, where other pandemics were plaguing the world, and where they're studying air quality from a bacteriological point of view, understanding how far air contributed towards the transmission of disease at the time. So climate conditions, so part of my research is to reconstruct them systematically, understanding how well they performed, and really being objectively clear where the limitations of the system lie, and also where the merits lie of pluripotent systems. And one thing I just want to highlight is when we're thinking about resilience of buildings, it's not just about looking generally how they're performing, but it's also putting a little bit of magnifying glass on periods of extreme environmental conditions, because there were actually historic heat waves. And one of these historic heat waves in Parliament was from 1856 to 1858, where there were exceptionally hot summer, where they experienced major overheating issues in the Houses of Parliament. The temperatures were noticeably higher than they were previously and for much longer periods, and how people at that time were responding to them. So this is just a few examples here of parliamentary debates where members were actually bringing up these experiences and they were debating about them. So this is the first encounter of actually climate extremes, even before the era of climate change that we're dealing with now. So the historic evidence showing us actually how people were responding to this. So here is a historic reconstruction, a diagram that produced of historic climate data of its time, to showing the type of climate variation that was encountered at that time, to really understand the thermal stresses that they were encountering and seeing really how the building was faring under those conditions. So, and we also find evidence of actually emergency measures that were taken to adapt to this environment temporarily. So they're devising additional ways of cooling the building, for instance, etc. So we are feeling really, we can see as a biography of the building, this operational adaptation that were happening temporarily over time to respond to this extreme heat. And I've done a study. So these are two articles with looking at the House of Commons, essentially the historic House of Commons, but also the contemporary House of Commons, and seeing how these buildings have adapted to climate over time and how the buildings responded to changing climatic conditions over time and so on, and what the role as adaptation was alongside operational adjustments. So we really need to talk about a socio-technical architecture as much as a physical architecture, because a lot of this relied on what people were doing. How were they responding to the external environment, how they were responding to the internal environmental use, and also how they dealt with that rather challenging condition of having users who complain. So have a building that's really responsive to those elements. And this was then enhanced through the scientific evaluation I mentioned earlier, and a process of continual adaptation. So we have actually an evolving architecture, even in a fine building like the Palace of Westminster, which we might think is quite original, but it has been continually adapted from an environmental point of view. And here is a study that I've done on the House of Lords, looking really about technological transition of climate controls from 1854 to 1966, understanding really how did these buildings adapt over time. And here is just a very basic timeline, and it's just a few points I would like to highlight here is that the original system was established in 1847, But in 1854, they were already modifying the original system in the House of Lords, making quite significant adjustment to the original design to make it work more effectively. So this is actually quite, within only a few years, the building started to be adapted environmentally. And this journey of continual adaptation continued over time, where people starting to modify window designs to, for instance, to provide more effective cross ventilation to the building. Well, the building was originally designed to be sealed, so they were continually adapting to that. And the building started to be operated differently. So that operational history is really important because it shows us how building really worked in the day-to-day rather than what the designers were originally claiming. And that's really critical. So here we got a drawing that shows that 1847 state, where the building was actually originally sealed. Air was brought in mechanically by a fan and exhausted through a tower. There was no intention at that point to open windows to help with the ventilation. The buildings were actually fixed in place. They couldn't be opened in the Lord's chamber in the original design. So in 1854, when Goldsworthy Gurney, another specialist, was brought on board and revisiting the original design and seeing it has problems, he was actually reversing the system and making it entirely stack-driven. So getting rid of the fans and also starting to introduce operable windows as a supplementary ventilation feature. So at that point, we have two systems in place, a natural system of direct natural ventilation and a natural systems of stack ventilation that relied on towers to ventilate the building. So here's a little close-up, and you might see in this drawing in red, the red elements are operable features in that system that were introduced now to provide supplementary cross-ventilation, particularly for cooling in the summer period. So we're opening windows, opening doors to create a natural airflow in the space to make this work. And we find, interestingly, historic evidence of these passive features of operable windows shown in the original configuration. So here's photographs in the 1920s. And we also got photographs that showing us historic shading arrangements to provide protection from solar heat gains in the summer period. So this was part of the keeping the interior cool, was to use shading. And these are no longer with us in the air-conditioned environment, but we find still remains of these shades, evidence of them, although no longer in use. Here, for instance, is a part of the building where we've seen cast iron blind boxes that are hiding the shades behind them, whilst the other windows no longer have any shadings on them because they've been removed since. And one thing that's really important when we think about heritage features, that's very often a big debate currently, whether it's acceptable to retrofit shading to historic buildings because they were seen as not compatible with heritage principles. But when we're actually going back into time, we're realizing that actually a lot of historic buildings, including major public buildings, had shading, external shading, part of their original design. So here's just two examples. We got here on the south end of the Westminster Law Courts, which no longer exists, and the Treasury building in Whitehall, they had external shading. So we find actually precedent of these things in historic buildings. And this will ask the question, should this mean that we should revisit this assumption that this is not compatible with historic buildings? So when we're looking at the House of Lords chamber is, what we're essentially seeing emerging with our changes I talked about by Gurney is that we have a building that suddenly operates in different ways rather than in just one way. So the building is no longer just sealed. So it might be sealed in the heating season, for instance, in the winter period to keep warm. But as soon as it gets warmer, people start opening windows, and this is staff that get involved to operate them in an intelligent manner and also use shading to manage the heat gains of the interior. So, and we got eyewitness reports of this also about the use of these auxiliary systems. We got written evidence alongside drawings that telling us what people were thinking, arguing about these principles. And we can then start to doing very detailed studies of really understanding how this auxiliary system works, where the doors were located, where the windows were located, to really understanding how these were operated and evaluate them, reevaluate them, how effective these might have been when they were in use. So here's a historic interior photograph of the House of Lords chambers, not the way you would see it today. You wouldn't see the windows in the House of Lords open because it's not air conditioned. The windows are permanently sealed. But in Victorian times, you would see those windows being swung open and the daylight coming in at times. So this is sort of historic evidence. And here's those floor plans where I've mapped those optimal elements of the natural ventilation strategies. We still find those mechanisms in the building. So in the House of Lords, windows still have operable section in them, although they're no longer opened. So the infrastructure for operating them still exists. And also we find historic photographs that showing us that the windows of the House of Lords, for instance, had shading. Also, not just the areas I shown you earlier, that the whole debating chamber was shrouded in canvas to keep the windows from excessive heat. We see on some of the windows being quite concealed, like small windows into corridors that were opened and so on to help with the cross ventilation of these spaces. And what's interesting is that the Palace of Westminster experienced severe damage in the Second World War. Most of the windows were destroyed as a result of blasts from the bomb during the Blitz, and particularly in 1941, there was severe damage. And the House of Lords chamber essentially was without glazed windows for a long time. So they had to remake those windows after the Second World War, when the building was still without air conditioning. And they were reinstating those natural ventilation strategies, and they were continually used at that time, up until 1966, when the air conditioning was introduced and the building became sealed. But we've seen that this adaptation measures wasn't just limited to the chambers. We're seeing it also happening in other areas, in committee rooms. The committee room, for instance, we find examples of double glazing, early forms of double glazings being introduced, operable windows being introduced that were previously fixed glazing to provide natural cross ventilation more extensively without the building, rather than relying on those systems I talked about. So they were complementing, and this through the management regime, that these things were kept in balance with each other. So we find that even here, a picture from 1976, where we still find evidence of some of these historic adaptations. Secondary glazing on the inside, we see even some temporary mechanical fans being put into the windows to help with overheating issues in those spaces. Now they have modern air conditioning in those spaces. And as really also concluding on that sort of element is, we need to understand this system. We need to understand them together as one system. So we got the system that are designed by the engineers in the original state, with flues and towers and so on. And then we got those auxiliary systems of operable windows and shades that are added on later on to make better manage the environment. And collectively, this we need to describe as the cumulative intelligence, environmental intelligence of the building, of practices that were developed over time. So this is part of the biography of climate responsiveness. So the building retained resilience through its ability to adapt, be more acutely adaptable to the environment it's built in. And it was in the 1960s, then in the House of Lords chamber, air conditioning arrived, marking really the end point of these practices. So at that point, these historic practices of complementary ventilation was no longer in use. And now comes this question. We're seeing now new buildings being built that draws on some of these principles that were originally adopted in places like the Palace of Westminster and other 19th century public buildings of using stack ventilation, are now coming back into fashion in newly designed public buildings, like theaters in particular, and university buildings, faculty buildings. So here is just the Everman Theatre in Liverpool, for instance, from 2014, has towers on the top for a stack ventilation system. We got the Slavonic and Eastern European Studies buildings in Bloomsbury, as an example, from 2005. These are buildings that are drawing back on the same principle. So the question comes now is, when we're working with historic buildings that then have these still in place, could we revitalize them and use modern technology, advance them, and build on that knowledge? So So we can sort of conclusion really that actually adapting buildings to changing environment is not new. So that's really important thing. And that we need to be, in order to understand how buildings were actually becoming resilient to climate, we need to understand the whole life cycle of the buildings. And we learning through that, not only the limitations of particular technologies, but also how far they succeeded by enhancing those systems or later adaptation to make these systems work effectively, passive systems. So, and extraordinary periods, as I mentioned before, are quite important to look at in this case. So can we learn something about the limitations of the system by looking at extreme moments of heat, of which there were several instances? And can we learn from that to seeing what the limitations of systems are? And also, we need to understand the buildings as operated systems. So how were the buildings dynamically managed over time? How was the management, how were these buildings managed under different conditions? And also, how do the buildings then continue to be adapted? And we need to talk about different kinds of adaptations here. So one of them are physical. So any physical changes were done to the fabric of the building. So particularly the adaptation of windows and so on, but also technological adaptation, which applies particularly to services. So how were the services changed over time? So heating technologies, the lighting technologies, etc., cooling, mechanical cooling, and so forth. And also operational adaptation. So how far do actually changes in operational regimes done by staff employed help to make the buildings work better? So we can talk about the latter really as a form of intangible environmental heritage, because non-physical is actually to do with a culture of building management that has developed over time. So I hope that gave a little bit of an overview over this sort of thesis of actually how to look at historic building as a way of understanding and revisiting the ideas of resilience. And I really want to end this talk really with these two questions. So how far can these historic experiences of adaptation offer lessons for climate adaptation today? Are the historic challenges really comparable to those challenges we are facing today, in particular? So these are sort of questions that we can ponder about, and this is part of the research ongoing at the moment, is to actually address those critical questions. So on that, here's a little list of a few academic sources that you might be interested in looking up if you're interested in reading about this. So most of them are actually open access. The articles in particular, they're open access sources that you can access online to study. Hi, Rosa.
Yeah, hi. Something is wrong here with the. Okay, I don't know if you. Can you hear me?
Yeah, I can hear you.
Hi. So thank you for this amazing lecture and for sharing with us so much insight of the past of Westminster. And I invite everyone to either write a question in the chat box or raise the hand to speak, to ask a question. So I think we have already a question here. If someone wants to raise their hand and just pose the question, that's fine. Okay, first question is from Susan Morandi. Do you think in the near future we can design and live in smart buildings that can fully adapt to any climate, not just with routine mechanical ventilation, but any material used in it can be used as a natural ventilation? That's
a very big question, isn't it? Very big question. I would like to respond to that question by looking a little bit in terms of the historic environmental principles, because actually this idea of intelligent buildings we now is sort of a big subject at the moment, in particular the role of artificial intelligence might play in that in the future, to gathering a lot of data of actually how buildings behave. And what we actually have seen in historic buildings is that people didn't have those computational means and data and sensors and so on to do this large extent of data gathering and processing. But what they're doing is they were going about the same sort of kinds of procedures of gathering data, analyzing them, and adapting them. So the interesting question comes with that is, could modern advanced control systems actually help making some of these historic principles work better than they have ever been in the past? Particularly if we got now much higher level and automating some of these controls and feedback loops. So the feedback loops in the 19th century were human feedback loops. Now we got computational technology that allows us to do this electronically. And we can gather data and do much more in-depth analysis than we could previously do. So there is an interesting prospect of actually integrating modern control technology with passive measures to make buildings more responsive. So there's a real prospect of that making this idea of an intelligent building much more workable through an automation.
Thank you. Thank you. I have another question here. There is an anonymous attendee, which is, the question is, thank you, Eric, that what was a wonderful presentation. Please, can you elaborate on the architect's agency, the building's user responsibility in the future climate adaptation and mitigation of our built environment in the face of the climate crisis? How can the next generation of architects learn more from the vernacular and indigenous well-tempered architectures alongside the integration of modern technological advanced, not to increase energy and carbon, but to be more efficient in our future designs? That's a good question.
Yeah, it's a big question again. I could do a whole lecture on that one. I guess what the core of that question is, I mean, there's actually more than one question in there, isn't it, actually? So one is about agency. So there was about the agency of the designer, the agency of the user, isn't it? So that's part one of the question, isn't it?
Yeah, that was about that agency.
And what's quite interesting about this, one thing is really important about particularly the agency of the user, because that's where often architects overlook that sometimes, that we design buildings for occupation and we hand over buildings. We don't think about what happens to them, how they're operated, and the stewardship question. So I like this idea of building stewardship. So a truly sustainable building require quite a substantial amount of stewardship to making sure that the original design intent and principles are stayed faithful to, and also that we can learn from them. So because if there's no engagement with the buildings in use, we never know how occupants experience them, how they perceive their success, let alone how measurements might tell us something about the building. So the occupancy engagement, in particular when you design systems where the occupant has actually a direct role in operating the building, then it becomes really, really important that agency is actually really seriously considered in the design. And what is remarkable, I think, about a building like a public building, like the House of Parliament, is it's extraordinary because it has important people as the main user who have the agency to actually say that they want the environment to be better. So this is unusual. If you're thinking about people who work in office environments, or people in housing, particular social housing, or people living in very poor living conditions because they can't afford anywhere, there are people impoverished in terms of agency. So this principle actually applies to everyone, and this ability to have agency in the building is very important, because you're feeling, actually, there's been studies being done that people actually feel more comfortable is a feeling they have some degree of control over the environment, or that their voice at least gets heard and responded to. And we find that in historic buildings quite a lot. And this applies equally to modern buildings. Whether we design a passive house standard building today, that question of how we integrate the user or the manager. So the manager as a mediator between user and owner in the operational building. So in public buildings, very often that the stage manager or facilities manager will involve quite a key role. And the House of Parliament is a fantastic case study, isn't that? How it was done historically and contemporarily as well. Whilst in private settings, the housing is more the personal agency. So that's one thing. The other one is about integration of historic system, modern systems, isn't it?
Yeah.
I mean,
Yeah,
I think
the next generation can learn about that.
Yeah. So the thing is, there are two curricula we're talking about. We're talking about the modern curricula of modern technological environmental design, and we have got a curricula of understanding historic principles. And what I think is the issue at the moment is that the curricula draws almost an iron curtain between the two. So there's a historic way of looking at things. Are they interesting historically? There often may be some lessons, but it's very limited. And then we're going for the modern. But I think what we need to achieve is to have the two perspectives coming more closely together in the middle, where we're really talking about the dialogue between them. So what are, for instance, vernacular principles really able to tell us, to inspire, to inform a new approach to design? And one of them is essentially rediscovering the role of architecture in creating optimal environments, rather than overly relying on technology. At the same time, we shouldn't try to always say that technology is bad, because it isn't. It's about the intelligent use of technology, a clever, intelligent use of technology in connections with clever architectural passive strategies. So it needs to be, we should try to avoid this schism or chasm between historic ways of thinking and modern ways of thinking, but also a discussion between mechanical versus passive. So now we need to really bring them in a dialogue with one another. And that is the thing about curricula. So if you want to think of future architects, I think people need to really overcome those ideological boundaries and see them in dialogue with one another. It's also a way of learning architectural culture by looking at the past and our current practices and seeing where they come from. Why are we positioning ourselves today this way as a history? So that's really important that we think this really as a culture of design. How can our culture of design today really engage with the architectural responsibilities of the role of architecture and what the role of technology in it and how they work together in a more intelligent manner?
Yeah, no, that was actually great. Is there any more question? I actually have a question if there is any. I don't think
There's a
any.
question in the chat from Henrik.
Okay, so thanks for, yeah, the question is, thanks for answering the question. So that's from Susan Morandi. And there is a thank you from Hannah Marchant in the chat, and many other questions. Thank you in the actual chat. This was in. So I don't see any. Ah, no, here we are. Thank you for answering the first question. And then I have another one, if it's possible. Do you think it's possible to predict the resiliency of structural and architectural components of a building as a whole to climate change impacts?
Oh, yeah, so I guess this question relates to historic building, I assume.
I assume,
So,
yeah.
So I guess what comes in here, mythologically speaking, is, I guess, simulation work. So what we can actually do today, I mean, with something the Victorians didn't have, is we have ways where we can model historic buildings against historic climates, against current climates, but also against future climates. So those modeling techniques will allow us to address that really important question: how would a building like the Palace of Westminster behave in 2080, for instance, with climate change projected data, which we have now available? Of course, that needs to be continuously updated as predictions of rises are continuously exceeded what they're predicted. But we can use simulation work to try and to do a stress testing of designs. And that will help us to designing actually into those historic strategies fallback mechanisms of resilience. And there is a big question comes in, is there going to be a cutoff point at which passive strategies cease to function the way that previously historically might have functioned? Particular issue that we want to think about here is extended periods of high temperatures. Passive strategies usually rely on diurnal swings between day and night. So if you have extended periods of extreme heat, the fabric will eventually come to an end where it's no longer able to absorb heat and help with the cooling, passive cooling of a building. You will then find a point where you probably rely on some form of artificial mechanical intervention to make that work, or we might come up with additional passive strategies of trying to mitigate that. So there's a very important question. So it's about the stress testing of a building, so simulation work to seeing, because we need to really think about the future rather than now. When we're designing anything now, you need to think about something 2050, 2080. Is this building still inhabitable? Or are we designing things that are actually obsolete by not designing for resilience, future resilience?
Thank you. There is another question here, and then I have mine if I have time. Sorry. So from Frank Herringer, is there any linkage between planning like on the moon or on the Mars and the actual questions you raised in this work? I wonder how much can be learned and adapted from both sides. Sound a bit silly, maybe, but that's a question.
That's a funny question, isn't it?
Yeah.
I guess what people say about, there are groups, research groups, who are interested in what's called design for extreme environments. So whether you think about designing something in an extreme desert condition, some people might argue that actually the designing for potential Mars exploration might be in a similar way an extreme environment. So the principles, in some ways, will probably not that different. But of course, the Paris of Westminster probably doesn't provide a precedent for how we can live on Mars, but it requires for us to designing systems for extreme environments. So resilience is probably something that we could probably learn from those probably highly technological systems, because we rely on creating to know a way that we can breathe and live. So they're going to be highly mechanically serviced environments. They're not going to be passive, that's for sure. Although they might rely on finding ways of keeping cool and protected and so on. But I think that's an interesting question. That's a good thing for students to explore how we're designing under very extreme conditions, because there's illuminate this idea of resilience in an absolutely fundamental way.
Thank you. So if nobody has another question, I have mine. What I'm thinking of from your research, the important, we can look at the importance of historical research, survey and mapping features of buildings in order to understand and to really get into and deeply understand the features, then specifically the features for the historical environmental approach that they had in the past. What I've seen in the practice, that often the pre-design phase is often overlooked. There is often not much time allowed, and therefore survey or analysis or historical research even is almost, I wouldn't say never, maybe I didn't, depending on where you work. For example, the approach in England or in Italy is a little bit different, but not everywhere there is this emphasis and attention placed on pre-design and analysis and survey. And so how can we train future architects, and how can we make this happen? Actually, we don't have we should also train existing architects which are operating now in changing and shifting a little bit, driving the attention to this topic, how we can do that. And that's my first question, and then I have another one if we have time.
It is a good question. I would say this project is quite unique in that respect. There's a large research project that I'm leading on this, starting off with purely academic initially. So I've been working on this for, sorry, my voice is just, for 12 years. So to develop this research, and with this project is this a heritage building, important heritage buildings, and in heritage buildings tend to be a more common thing to study a building in advance than it is, for instance, with less heritage significant buildings. Because there needs to be a lot of justification for change, need to be grounded in a good understanding of the historic environment. And the Palace of Westminster is also unusual as it's a highly technologically complex building. I mean, there are other public buildings of that kind, but this is incredibly complex.
I know.
So, yeah, and it's through having the client recognizing that, and me as an expert in this area leading this research to enable this is quite unique, I think. And I feel really privileged to have that opportunity to actually implement this idea of environmental design. One thing I want to say, though, is that one problem, I guess, with architectural design is when you see this, I see this in design studio, and they sometimes have to pull back the students and say, actually, and when you design a building, and particularly if you're using adaptive reuse, if an existing building and so on, if you have an existing building, it might even be demolished and you want to reuse materials and so on, to look at embodied carbon and so on. You need to understand those buildings first before you jump the hoop and go straight into design solutions without actually understanding what you're dealing with. So there's definitely a change in mentality. And of course, there are time constraints, practical time constraints. But I think even with constraints, as architects and designers, we can probably do a bit better job of having even more time to understand what we're looking at and not to go straight into design concepts, but let a little bit studying. And this might even be on new design, applies the same, where we might looking at alternative ways of doing things rather than just the way things are always done.
Yep.
So in education, I think there's an opportunity to actually still at least that ethos within the studio, even if it cannot be done to the extreme as this project, where the whole research project is done. And the RBA, that's interestingly, the Royal Institute of British Architects has produced over the last few years actually some guidance for architects on the role of research, because architectural practices are very often have a bit of a problem of not necessarily fully recognizing the value of research to competitiveness, the possibility of innovation. And there is, depending on the size of practice, there are different kinds of research. So there is the kind of research that is literally the basic research you need to deliver a project that feeds directly into detailing or something, standards, and so forth. Yeah. But you get also some projects that go beyond the individual research project, but might be typologically. So if you have a practice that focuses on office design, museum design, you probably would have spent a lot of time understanding and doing a lot of fundamental research, sometimes in collaboration with the university, into understanding critically the state of the office building, to know how is the world of work developing. COVID has an impact. So we can't design workspace that we did 20 years ago, even 10 years or even 5 years ago. Things are changing. So these are problems that need to be beyond individual project to inform the way we're designing. And that is when we're starting to break the ice of conventional practice by actually starting to innovate. And some of the research project might be sitting outside the immediate design project. They might be typologically focused. So you don't have to chase. You don't need to rush a project because you can't rush research. That's one thing that designers very often forget. Is academic research, you can't shortcut. You end up otherwise in quite significant problems because of the rigor that you need to really question things in great depth and accepting that a research project doesn't go to the timeline that the manager maybe wanted to be. And that honesty is absolutely fundamental. And it might be that in an architecture practice context, what I would recommend is building over time a portfolio of research that you build over several projects so that you actually understand fundamental principles, because all of these things, you won't necessarily need to reinvent the wheel each time.
No,
So,
definitely.
yeah, so if you're looking at a particular practice, tend to focus on housing, offices, and particular public building design, and they might have particular environmental techniques they're particularly interested in, to really develop expertise in those areas. And that can be then done over generations of buildings that you're designing. And each building then becomes part of the research process itself.
Yeah, no, exactly. It's each building that I was, each building at least requires a survey and requires a mapping on its own before starting the design. And that is actually probably the issue that we are facing currently. Just a question, if from your experience in Palace Westminster and surveying and working on the project, have you seen an increase of decay phenomena in materials and systems since the building was tied up and air conditioning was tied, sorry, and air conditioning was put in 1966? Kind of
Do
kind
you
of
mean because
the decay phenomena or of
do you mean
materials.
because the type of artificial environment, or do you mean the equipment?
No, the equipment. I mean the material, the original material of the building that were, in the cycle of the passive ventilation that was there before tightening the building. Have you seen in the records, in historical records, any increase of problems in terms of degradation of materials or original materials, so building materials or systems?
Yeah, so material certainly over the whole lifetime, but not necessarily as a result of the switch to air conditioning, but more generally speaking, there has been a lot of deterioration of timber, for instance, ceilings.
Yeah.
And a lot was to do actually with Victorian lighting technology, causing quite a lot of damage.
I was thinking about if the relationship between, ceiling and not allowing breathing through walls and
yeah, okay. Yeah, no, I haven't encountered any of that. The building isn't that sealed. That's the
okay.
thing. The building, even if it was air conditioned, it never has been hermetically sealed. The building is incredibly drafty, even now. So that will be a really important issue now with the forthcoming restoration program, when actually an increase in the sort of retrofitting, probably there needs to be very careful consideration of actually introducing insulation, in particular, of losing the breathability of materials. So that will become a really big study as part of this retrofitting, what is actually feasible. So the interesting thing is about the introduction of air conditioning in the 50s and 60s and in the 90s. There wasn't part of that wasn't about insulating the building retrospectively. That wasn't part of the scheme.
Yeah, and in fact, that's the major problem probably we are going to face, is that some approach to retrofitting is kind of sealing the buildings and making the building. Yeah, but that's
that's
our risk.
Very valid question, and it's part of the problem, part of the challenge of
That's
actually
where
dealing
your
with it.
approach and methodology, your approach should make people thinking, and architects and professionals think. Your research is great in that, I think.
The interesting thing is actually, one thing I want to say that these questions are not new, because the Victorians were thinking about this very carefully. So you find actually that, for instance, there were condensation issues on the walls in some of the fine areas. And you can still see the traces of that today.
Wow.
The marks left by condensation so they introduced secondary glazing in some areas to create condensation on single glazed elements. So there are an interesting example. Also, roofs were insulated, so they had a historic method of ventilating roofs. Those insulation techniques have been disappeared now. They've been removed since. So the building is actually, so there's an interesting thing of actually looking back at this historic experience and further back in line to seeing actually how these buildings were behaving historically. So not just today, but historically, we can draw lessons from them. Particularly if we're thinking retrofitting in a similar way that did then.
Yeah, in fact, I think we really need to introduce, probably reintroduce or stress more on the importance of learning historic features and the history of the building and its systems. Nowadays, I think it's really often overlooked, unfortunately.
Yeah, because one thing I find really fascinating when you read the literature written in the first half of the 19th century. So in doing my PhD in Cambridge, it was on the history of glass structures. So glass houses and the first human designed glass buildings, like the Great Exhibition of 1851, etc. Yeah. What is remarkable is the knowledge, building physics understanding that horticulturalists developed in the design of horticultural buildings. And the application is really, I find it really remarkable. I think there's quite a lot of architects today that would probably be less knowledgeable than these people were. I find that really remarkable. Despite the fact that we now have a much deeper understanding, so we can now simulate all of this. We have probably a more precise understanding of it, but the actually fundamental principles were very well understood and documented in the literature of its time.
Wow, that's
fabric. So moist, for instance, the problem of mold growth, humidity in buildings, we think it is a modern problem. No, that was already discussed then really extensively, and people come forward with ideas of how it could be mitigated. So,
I was reading an article on the glass architecture and the ventilation system applied to the Paxton Crystal Palace. It was really interesting. I've done a little bit of research on your, but it's really interesting that, and the way, the way the actual modern glass architecture doesn't really enable that. It relies exclusively on mechanical ventilation. I think that's also a lesson that we should learn.
The interesting thing is there's glass architecture before and after air conditioning. And interestingly, a lot of the early modernist glass buildings, we're thinking about Mies van der Rohe's Crown Hall, Lakeshore Drive apartments. They were designed originally without air conditioning. And as you would expect, they have problems with overheating. And the Crown Hall is interesting. They have features built in it in an attempt to try and manage it through quite simple means. It has a mechanical extract system. It has some louvers at the bottom of the windows. It has got some blind systems. So it's an environment that's actually educationally probably quite useful for any architects who are designing any glass skyscrapers. If they have ever learned to design architecture in a building like that, they will actually realize what the reality is of designing glass buildings and developing an alternative tradition of glass architecture. There's probably less to know, because the design of glass towers today are all designed to be highly mechanically serviced. Even if there's an attempt to make that servicing less reliant on fossil fuels, they're still incredibly energy intensive.
Yeah, no, exactly. But I think this part has been quite lost in terms of in the technology and in our School of Architecture, kind of the teaching of how building works, not only from an aesthetical point of view, but also from a technical and mechanical, not mechanical, but technical point of view, an environmental point of view. I think that's yeah, we should probably do a lot of work, put a lot of effort in learning the past, basically, in learning from the past, learning from experiences.
Yeah, so bringing it together in dialogue with our modern
Yeah,
technology environment teaching. So,
exactly. Yeah,
and
I
one
don't
thing
know.
I would highlight, one thing I would like to highlight though, one thing
Yeah.
that, because I got student specialist modules, I got one on the historic environment and one contemporary net zero carbon design. One thing that I always think is really important to highlight is that when you're looking at something historic, making sure that you acknowledge that as distinctive from the contemporary thinking. That's always very clear to highlight the difference, but then also afterwards, then looking at where the connecting points are. So not to, because the danger is that people just interchangeably look at historic and modern buildings and don't really realize the difference.
No.
And even passive principles that are used now in modern buildings have some family resemblance to historic ones, but they're also distinctive differences. And these are important to understand. And that's where the learning happens, to my mind.
Yeah, I know exactly. Kind of understanding the intent, understanding the logic behind, and also what the building have to respond to. I think that yeah, that's great. We really should pay more attention to this. I don't know if our time is up because I think we are just the panelists now. No, there are more participants, so there are people
Yeah,
still.
we're a little over time, but we still have some people on the call.
Yeah.
Um,
Someone else wants to ask some question, otherwise I think no, nothing comes. Yeah, many compliments for very interesting, and yeah.
Thank
Okay.
you, Rosa, for sharing. I'm sorry my voice is gone. I
No,
was
sorry. Yeah,
doing teaching both here at Kent and then earlier in the week back in Cambridge a bit. So doing a lot of talking. So
yeah. Thank you, and I'm really enjoying your book. I just started to read it, and I'll be in touch maybe to ask more.
yeah, sure.
Thank you very much. Thank you very much to you for your time and for staying with us today. I think I don't know. I'll hand the floor to Francesco or Korshan.
yeah, thank you very much. Yeah, just wanted to echo my thanks. Thank you, Rosa, for moderating today's session. Thank you, Henrik, for being here for that great presentation and for being able to stay a little longer to go through such a great discussion with our guests and with Rosa. All very interesting. I'm sure everybody has learned a lot. Also, thank you, of course, to all of our attendees for joining us, and thank you to everyone who was able to stay until the end. I know we went a little past the scheduled time, so really appreciate all of you who could stay a little longer than the scheduled hour. Excuse me. I don't know, I got something in my throat as well. So just quickly before we go, I just wanted to share my screen for the next talk. Just sort of a reminder to everybody, the next session will be on March 5th. The speaker is Dr. Denise Ikiz-Kaya, who teaches at the Eindhoven University of Technology in the Netherlands and will be speaking on building a climate resilient heritage future together, inclusive and participatory processes for impact assessment and climate adaptation planning of coastal heritage. So please remember to mark that down on your calendar, share it within your network. Registration is always open until the very last session. So yeah, please feel free to share this with anyone who might be interested. And I think that's it for today. So thank you again for everyone for being here and for that great presentation.